Hi everyone, my name is Jan Bronicki. I'm going to be talking today about Flatcar Linux, which is an immutable OS that is mainly optimized for containers and Kubernetes. So let's start. First of all, who am I? I used to study here. I'm a graduate of Politechnika Wrocławska, that is the Wrocław University of Science and Technology. My engineering degree was in Automatyka i Robotyka at the Faculty of Electronics, and later I did my master's at Faculty of Mechanical Engineering in Zarządzanie i Inżynieria Produkcji. Right now I am a Flatcar maintainer. I work at Microsoft as a software engineer, and my job is to essentially work on open source. We also do a little bit of Azure internally when it comes to the low-level stuff with OSs and mainly Linux. Here is my GitHub handle if you're interested, and let's get started. So what is Flatcar Linux? It is a minimal container-optimized Linux distribution. Throughout this presentation, we'll try to understand what that is and why it might be useful or might not be useful. Minimal is, just to give you like a ballpark, it's about 300-something megs RAM when idle. And I think the most minimal when it comes to disk usage you might need is like 8 gigs to install it, right? So it's pretty lightweight. We do our best to basically ship as little as possible. So it is community stewarded. It is made for running containers. We basically focus on doing only that and doing that well. We do think about our operating system as a container image. So if you've ever used Docker and you wrote a Docker file, then you provision that container. We think in that way about an operating system. So it's that layer between your hardware and your user space. We take that and try to not make it an issue for you. It's mainly for orchestrated as well as unorchestrated stuff when it comes to containers, so Kubernetes, Docker, Podman, and many more. Essentially anything that allows you to create that virtualization layer, we try to support it. Flatcar is also immutable, which might be new to a lot of people, and how that works and why it's not really an issue we'll discuss later. But what it does is essentially you cannot change anything on the actual operating system, at least none of the binaries. You cannot install packages. There's no package manager. You get what you get, and that is kind of it. The OS itself is an image. It's not an ISO. You do not install it. You provision it. And how that works, we'll see later. We also do have a feature for automatic updates, so we do not have to actually care about updating it. We try to make it essentially, well, I wouldn't say maybe maintenance-free, but at least hands-free. So you just kind of set it, forget it, and it kind of runs itself. So first of all, what does it mean that it is community stewarded? Who are we? Flatcar is right now a CNCF project. So yesterday we had multiple talks talking about open source, what it is, how it works. So I'm not gonna be repeating that. I think we all kind of get the gist of it. CNCF, that is the Cloud Native Computing Foundation, is a sub-foundation of Linux Foundation. Flatcar was initially forked from a OS named CoreOS. It was a also container-optimized immutable distribution that was initially based on Chromium OS, and even before that on Gentoo. Then CoreOS, that Flatcar fork was created. It was mainly developed and operated by a company called Kinvolk. It was a German company specializing in cloud, open source, and consulting. Later, Kinvolk was acquired by Microsoft, and after that, Microsoft gave away Flatcar to CNCF. So if you're wondering who owns it, essentially the CNCF owns it. So no matter what, essentially it does mean that no one can take it away from you. It's like the Linux Foundation itself owns it. And we were accepted to CNCF on the 2nd of August on 2024. And right now we are in incubation. awaiting graduation. So this is our team, at least parts of it. We have almost 20 full-time maintainers and about double that contributors that are kind of sticking with the project, and much more when it comes to contributors that are kind of doing the drive-by commits and PRs. We work at various companies. I know there's a picture of Microsoft, but that's kind of a booth we were using. So it's not primarily Microsoft. It happens that I am from Microsoft and a few of my colleagues as well. We work for various companies and from various countries. So for example, we have Cloudbase, Stackit, Microsoft itself. There's a few more. We are based in various countries, mostly Europe. So if you want to reach out to us, the European time zone is going to be the easiest for you. I think we're in France, Germany, UK, Poland, Slovakia, Romania, and so on. We are community stewarded, so here we have more organizations that kind of do contribute to us. We always do want to accept contributions. So like, for example, yesterday, I think someone was showing an example of a project that wasn't really accepting contributions or issues. That is the opposite. We really want everyone else to be maintaining that, apart from, for example, Microsoft and the companies that do it today. Who do we collaborate with? It's mostly our upstream. So right now we're basically our upstream is basically Gen 2. The CoreOS is also a little bit of an upstream. We do share some of our tooling with them. However, basically our package system and all that we used to first build Flatcar is all Gen 2. We also do contribute to Grab, systemd, and other cloud-native projects and tools that we basically just interact with. We do have a philosophy of upstream first. So if there's anything that we can do and kind of helps, to basically better the community as a whole, we try to do that in the upstream first. Flatcar runs everywhere, and we really try to make it happen. We are an image-based OS distro. That means we do prefer to be virtualized. That can be your primary cloud provider, like Azure, AWS, GCP, and much more. Like, for example, Akamai or DigitalOcean, but also your simple virtualization software like Proxmox, VirtualBox, QEMU. We also do run on bare metal. We do run on bare metal, I would say. We do sometimes have problems. It's not easy to do with a distro that you want to be keep minimal. However, we do have even like big companies that run Flatcar on bare metal, and they do serve that as their Kubernetes offering, so it does actually work in production. You can very easily, of course, interact with us using Terraform, Go bindings, APIs of various kinds. So we kind of try to make ourselves very generic and definitely not vendor locked in. Here are some of the companies that publicly state they use Flatcar. One of the challenges of having a distro that does not spy on people is that we do not spy on people, which means that we have no idea who uses us sometimes, unless they decide to tell us, right? So here's, for example, Adobe, AT&T, DeepL. There is much more. Some of it I cannot talk about for obvious reasons, right? But it is a fairly visible distro in the cloud-native space. You can find most of our information, all of our links to socials, chats, whatever, on our website, flatcar.org. Also, we do basically everything on GitHub. It's just called Flatcar. It's very easy to find. If you're interested, please feel free to take a look at it. We are also as open as we can be. So all of our developers, community people, we do not only do our work online and in open spaces, like mainly Discord, Matrix, sometimes Slack, which you can just join. We also host every 2 weeks office hours or a DevSync, which you can just join if you would like to. It's open for absolutely everyone. If you're just interested, maybe you have a question, or anything really. So what is it and how do I use it? Let's see. If you Google Flatcar, assuming you do not have a Google feed contaminated with Linux, it will show you something like this. So this is technically what a Flatcar is, at least when it comes to trains. And someone had the idea that, there are containers run on it, right? So how about we are the Flatcar, we're, that connection between the traction, the real world, and whatever you have in your container. And that's kind of where the name is from. The general purpose Linux user experience philosophy is that of mainly having a gazillion of settings to tweak and things to fix along the way, which if you use Linux, you know that very well. This is not what we want to do. So what we strive to do is to be a light switch, essentially be on and off, and in whatever configuration you set it up. We really want to be an appliance for you. We want to be boring. We want you to kind of forget that we even exist. When you're using us, we want it to be very basically simple. So how do we do that? First, we start with functionality, not features. So if you have a general purpose Linux distribution, you do things like, for example, you choose your shell, maybe a desktop, if it's a server, of course not. The language stack, you manage updates, backports, new repos, all that stuff. You think about features like this version, this package, all that stuff. You need to update this, maybe downgrade that, patch this. You build the system you want. And the components, of course, they do shift. And this is mainly the issue that is the predominantly the sport of SRE and other infrastructure engineers. So what we do at Flatcar is we choose the packages for you. We bake them into the image, and you cannot change them. Don't get me wrong, if you really want something to be added, you can just approach us, and we can add that to the image, if that makes sense. However, we do try to make it minimal. The whole operating system updates automatically, so there's nothing really for you to do. And if that update fails, it rolls back to the previous version. How it does, we'll discuss in a bit. We essentially strive to deliver that light switch, that abstraction layer between the physical world and whatever you are doing when you're running your container, application, whatever workload. One more thing that kind of might be new to newcomers is that Flatcar is provisioned. It's not installed. We do not have an ISO file. You do not download it and just click through stuff, right? You do not make any choices during the actual setup. It's not interactive. It's supposed to actually be kind of unseen, right? It just works somewhere in the background. What that creates is that on a normal distribution, every machine is slightly different, right? With provisioning and OS image, every machine is identical to the actual bit, right? So everything in our image is basically full of hashes. And one thing that we do use is DM Verity, which I will mention also in a bit. That means that if you change it, the kernel panics. So you're always certain that this is the OS image you were running initially, and it is the one that you downloaded, right? Which essentially prohibits any software that is like malware or just errors in the disk, for example, to break your deployment. We use declarative configuration. It's a text-based YAML file that essentially just outlines how you would like the things to be set up on the system, what workloads, where, when, how. And you just do that. You do that upfront, and that's it. It's essentially the same idea like you would be writing a Docker file, for example, right? So this is kind of the user experience, which we'll show in a bit. You first create your declarative configuration. So you write that YAML file. Let's say I would like a container with my website to be running here on boot. Then you provision that OS image with that configuration, and it just works. At least that's the idea. So one thing that is very important to mention is that it is immutable by design. So when we provision that system on the first boot, the base OS does not change after that. So if you get a package A, which you shouldn't be using anyway because you're supposed to containerize everything, it's going to stay that way. The OS is read-only. It's mounted as read-only. You cannot change anything. If you go into user bin, whatever, and you even like sudo rm, it's not going to work. If you even try to remount it, it's also not going to work. And if by any chance it does change something, the kernel will panic. Now that panic can be, of course, caused by, for example, a disk failing, right? Partially, for example. There are no individual packages that are being updated. It's the entire OS that is being swapped out when that happens, and that essentially is supposed to keep your system away from configuration drift. We do share something called system extensions. So one thing that we do is we do try to be minimal. However, at the same time, for example, we'll not be shipping all of the runtimes for Docker, Podman, Kubernetes, and all that. For that, we use system extensions. How they work, we'll discuss in a little bit and show, actually. So first, how do our updates work? When you install Flatcar, and just bear in mind that this is a very minimal distro, you will actually have the OS partition duplicated. So there's going to be first two exactly same partitions. One is going to be running, so the grab bootloader most likely will choose the A, for example, and boot into it. Then when, for example, there comes an update, the second partition will be overwritten with that update, and upon a boot, it will be booted into that second partition. Then the first one, A, will be also updated, and that way there's essentially no overlap. And also, if the update fails for whatever reason, it will roll back to the initial partition that did work. So there's no intermediate states. It either works with the new one or just doesn't and rolls back to what was working before. And we are, of course, notified, and we try to help you. We do not really have versions like you would use in Ubuntu or Fedora or a normal distro. So we do not go and download that version, and that's kind of it. In our case, you download channels. So our channels and the OS itself, it updates automatically, although you do have full control over that. So if you really want to never update, you can just set it to never update or control any aspect of it directly. What we have are channels. So when we have an OS image that is, a bunch of commits on main, every commit on main is fully tested. Now, what we mean by that is that it is both unit tests that have run hundreds of times on every commit and every PR. That is the integration tests that have also run on every commit and every PR. And these are also production tests. That is about 120 scenarios, I think, we have across every cloud provider we officially support, and some that we kind of support or we have community support. So every alpha release is already fully tested. Our scenarios are kind of everything from, hey, let's just spin up a simple container, to let's have a cluster of Kubernetes running and doing something. We do release every alpha every about 2 weeks. We try to do that. And every beta is a promoted alpha release that has been working fine for people for about 2 months. Then, after 3 to 4 months of the beta release being good, we do promote it to stable. And about a year, if we know that a beta is really good, if the stable is really good, we do promote it to LTS. And that LTS is supposed to be essentially a golden image for you. So we're going to show some demos. to basically show you how it works. Are there any serious questions right now, or? Okay. So we mentioned that we have the configuration that is essentially a YAML file. And here I do have a few examples I'm going to show you. This is the simplest one which you can have. Our configuration uses butane, which is essentially a YAML file. And then that configuration gets added to the image, and when it's being provisioned by whatever you choose, be it a cloud provider or a virtualization software, it attaches it to the OS image. The OS image, upon the first boot and the first boot only, uses these sets of instructions and configurations and creates your image for you. So right now we're going to try to do that with a very basic example. I'm going to be using QEMU. So first we need to transpile that butane configuration, which is the YAML you can see here. This one is essentially empty. It just adds my SSH key, so I can, in any case, SSH into it. It creates a, wrong demo. It creates a JSON file, which is essentially identical. However, this is what Ignition consumes, which is our daemon that consumes that initial configuration file. Then I'm just going to be running a helper script that essentially spins up QEMU. That helper script is available on our website. It's very nice for iterating locally. And when we run it, right now I'm going to be running it in QEMU locally. It just boots. It will use that configuration. In our case, it will not really do anything. However, it should spin up in a few seconds. So this is it right now. If you were to be dabbling with that locally, you can just turn it off. Then after that is done, we can maybe move to a slightly more complicated example. I don't know if there are any questions right now. Maybe it's not obvious or... Okay. So this is a slightly more complicated example. What we're going to be doing here is this YAML file, as you can see, describes some stuff. For example, we can say, hey, create a file. I would like that file to be in an etc hostname. We do not have every part of the OS read-only. Some of them are, for logs and stuff like that. So there is really no point in doing that. etc is kind of similar. We can create a hostname. We can create a script that, for example, says hello. And just to mention that Ignition is not only a Flatcar thing. There are other distros that use it. We just also use it, and we also try to contribute to that. Then we use systemd, which we do rely on heavily when it comes to our workflow, to create a systemd unit, which simply means a daemon. That, for example, in our case, spins up Docker with the Hello World container, which is the available online. We also create a small Nginx Hello World example, essentially. So what's going to happen is on the first boot, Ignition is going to read that, and it's going to paste in this content of a file somewhere in systemd configuration and create a service that is called this here. So let's actually do that. So first we do need to transpile our configuration. So from that YAML file, we're right now in Ignition, which kind of looks like this. Let me just wrap that. It's essentially the same thing. It's just that Ignition consumes a JSON instead of a YAML. And then what we can do is we can just run it. Actually, I think this is the same call. By the way, these demos are on my GitHub. You can just take a look at them. Also, we do have a very nice learning series on our website in the documentation section. By the way, here you can see the both partitions being visible. Do not click it yourself. It's just go with default. And if you're in production, you will most likely set that grab menu to be 0 seconds anyway. So you can see the container destarting. We're in the system. Usually, you wouldn't even be looking at the actual shell output of Flatcar. You would just be seeing the containers running using your telemetry. However, we can check that they are running by, for example, going status. I think it was called nginx demo, or whatever, really. We can see this, and if we go we can see that the Docker container ran. And that is essentially right now baked into the operating system. So we have a systemd unit that will be running that hello world during the first boot. So this is a fairly, let me just demos, of course. So, okay. These were both fairly easy examples. However, I do think they show a kind of a basic principle of how we would like to use it. Essentially, we do have that Docker-like file that is our configuration. That configuration gets baked into the image, which we later spin up. And similarly to, for example, Docker, you wouldn't SSH into it and like finish your configuration, right? You would do that in the Docker file. So similarly, you wouldn't do that in Flatcar. I'm just getting into that to show you how it works and that it does work. So the next example is a bit more complicated. So here we're going to be spinning up a hello world style local Kubernetes cluster. So if we do not ship, for example, Kubernetes and the image is immutable of the operating system, how do we get that Kubernetes on the actual system? So what we do is we use something called system extensions. This is also something from systemd. This is a precompiled by us Kubernetes program, essentially, and it is also signed. So it will become part of the image, and that also, if this gets changed by an attacker, for example, it will also fail the system. So it follows the same DM verity principle of this is known to you from our website. You can check the hash. You can double check it. You know this is the same thing running everywhere. So here again, we do create some systemd units. We essentially just set them to do like a Kubernetes hello world with just spinning a bunch of random containers. So if we just, I did have to prepare a alternative version of running this in case we do not have internet, but I think we do. So if we just go here, we also need to transpile it. So we have that our text configuration. We just create the same file but in JSON, and then we can run it. No. There we go. This one might take a second because it does need to have download about 150 megabytes, I think, of the actual Kubernetes sysex, which is that binary package we talked about. So let's just give it a minute. Okay. While it is spinning up, we can try to see if it is right now. We'll probably get an error because the Kubernetes kubectl in it is working right now. So we can give it a little bit and see if it works. There is some noise on the std out. That is because you usually do not use it, so we just include it here. Okay. So we can see that all of the systemd unit additions that we did worked. So during the first boot, these files essentially with that configuration were added to the system. And on the first boot, it read that and executed these kubectl commands of spinning up a few hello world pods. So this is the main workflow you would be using with Flatcar, which is that configuration, provisioning, having the actual OS provisioned with whatever you have running on it, and that's kind of it, right? So it's the same like with containers, but a level of abstraction in between that hardware through the operating system to your workloads. Let me just exit that. Okay. For some reason, I cannot click the X on the QEMU I guess demos. So right now, we can actually try to provision it somewhere on a cloud. I'm going to be using Azure just because I have free a free tier kind of available to me. You can do it, of course, on any cloud you want that supports us, and like I said, most of them do. So we're going to be running a hello world example again. So we're going to be telling systemd, hey, when you're booting, please run the docker run hello world, and that's all it's going to be doing. We are also adding our public SSH key so that I can show that I can SSH into it, which you wouldn't be doing anyway, but just for an example sake, we'll do that. So again, we're going to go into the demos. Let me just copy the commands because I do not remember them. So again, we're creating a an ignition file, which is that JSON file from our YAML file. It's the same thing, basically that configuration that Flatcar would receive initially. And then what we do is we do tell Azure. We can do it also via the UI, but I'm just doing it here for the sake of kind of time because, well, UI is UI. So the first thing on a cloud provider we might have to do is accept the terms of service. This is an open source license like any other. I think we're using Apache 2 here. It's just that Azure still needs you to accept that. So after that is accepted, we can tell the Azure CLI to please create a resource group. I'm going to create one in West Europe. So if we go here, we should be able to see a resource group created. This is my personal Azure subscription. Okay. Yeah, we can see it here. Then we can use something like this here to provision the VM itself. The only thing that is kind of different, if, assuming you've used previously Cloud CLIs to do that, is that in here we do provide custom data. This is that custom text-based configuration of ours. So this is that file here. And basically this is the only thing that is kind of different about it. So we just ask it to create it for us. It will have that hello world example. Well, this may take a minute, but we should see it spin up in a few seconds. We'll also have a example with Terraform. It's usually the best way to do it for obvious reasons. If you're running a production environment, you wouldn't have to do the translation locally. There are Terraform modules for that. And kind of with that setup, you would essentially gain a fully infrastructure as code setup. So let's see. Of course, it's probably going to be taking a long time because I'm actually showing it to everyone. Okay, so here we can see our VM being created, and it does already have an IP. Good. Let's just let it finish. Okay, and now we can SSH into it. So So I'm actually SSH into that Flatcar VM running on Azure. It's in West Europe. We just SSH'd into it, and we can check if our configuration worked by running, for example, hello world. And it did. So we can see that the system file, sorry, the systemd unit we supplied in that file got to that VM. It listened to it. It created a systemd unit that did run that Docker container initially on the first boot. And we can see the output from that here. So the last example I'm going to show is a Terraform one. So this is a sample project, so obviously you would have in production your own setup with probably a lot more stuff in it. However, this is a fairly minimal example. We just create a virtual network, a VM, we connect everything to each other, and that kind of spins up. I'm using OpenTofu here. However, of course, normal Terraform will work. All you really need is that provider itself, and they will do usually just support it. So let's actually do that. I do have a make file to just do it fairly quickly, so we don't have to wait for it. Sorry, deploy. So we do that transpilation from a butane config, which we have here. This is again our very simple systemd hello world example. And we just tell it to use that in the Terraform code. We do supply that in here. So when we have the resource of an Azure VM, we just tell that the custom data field would be the base encoding of the ignition file, which is our JSON file. Yes, we do want to deploy it. So this will of course take a minute. And of course, Azure being Azure, it's slow.
Sorry, I will give you a microphone.
So in the meantime, why do we actually use Docker? Why we cannot just deploy it directly on the Flatcar? So for example, Postgres or any other service directly on the Flatcar?
So we do have a minimal set of tools installed on the operating system, but the simplest answer would be you would have to install Postgres, and you cannot install anything on the operating system because it's immutable, right? So.
You do it already with Kubernetes, so
yes.
As a system extension. Why cannot we deliver install the Postgres in the same way?
So when it comes to what we supply, right? We supply essentially enablers, right? So Kubernetes, Docker, Podman, anything that enables you to run containers, right? This is Linux, and it's open source, so you can just fork it and actually screw the immutability thing and install Postgres like next to the kernel. Like I don't care, right? You can do it, right? It's just it wouldn't be Flatcar anymore. So if you do try to use it in the OS that we ship, it will not work. So we do have a set number of sysx in a repo called sysx bakery. We do keep adding more and more. So we have like Wasm runtime, I think, like Podman, Kubernetes. There are some drivers for NVIDIA. If you have an idea for what we could add there, like go ahead and, it's very easy, relatively speaking, to add it. It's just that you yourself, you can create your own, version of everything separately and do it. It's just that it kind of defeats the purpose, right? So right now, I think we do have our VM stuff. Is there anything more, or?
So actually, I have a question. Do you ship for ARM64?
Yes, we do. Sorry, I did not mention that. We do ship for ARM64. It's also fully tested wherever we can, because some providers just do not have like an ARM offering, right? So if they do, we will test it on that. We also try to we would like to work on RISC-V in the future. We do have some folks that are really interested in that. So if there is someone interested in RISC-V and you would like to see a distro around RISC-V, like, you're very welcome to come and take a look and contribute. However, right now it's just x86 and ARM.
Okay, thank you. I will check if it runs on Raspberry.
I think it should. On bare metal, like I said, it can be bumpy, right? However, we really do want people to run it on bare metal as well. We do have like actual companies that do offer that in production as a Kubernetes offering, running it on bare metal. It's just that, there might be problems. So if you do have a problem, feel free to, join one of our chats, post an issue. We'll be delighted to help you. So I think we do have it running. So if we, again, SSH into it, which we wouldn't normally do, but we're just showing how it works. Again, this is provisioned by Terraform, and we can see that the service actually worked. There you go. And yeah, when it comes to running anything locally, just testing out Flatcar and seeing how it works, all you need is essentially a virtualization software of your choice, preferably QEMU. I know you can do it on Windows. I've never tried, to be honest, like natively. You can for sure do it on macOS, and of course Linux is Linux, so it just works there. When it comes to building the operating system, I do not really have a separate part about that because it's a bit more, advanced. However, it's very easy, relatively. You can do it in 3 commands. We have an SDK container with all the tools, and you just do like build, and it just builds. So it's very easy. If you would like to tweak something, maybe add a package, change a flag in the kernel, anything, it should be very, very easy. So thank you. That is kind of everything I want to show. I know it might be a lot to some. It might be new. If you would like to, please check out our flatcar.org website. You've got links to everything there. And if you want to chat to any one of the maintainers or me, just join our Discord. The Discord server is very new. Like, we created it like last week, so it has like 30 people, so don't be surprised by that. Our Matrix channel is much older. It has much more people. Thank you.
Thank you, Jan, for presentation. And we do have question from the stream. Mm-hmm. By the way, you can ask questions on the stream using the link linuksowa.pl/pytania. Okay, and the question is, in case of very, very large custom apps, let's say written in Java, which is difficult to pack into the container, however, I would like to run it on a Flatcar. How to do it?
So we would preferably try to run it on the container itself. I'm not really sure why there would be an issue with packing it into a container. I mean, you can just make the container bigger, if that makes any sense. We do not offer a Java runtime locally. I think we do offer Python, just in case, because it's, it can be useful for some tooling. However, if for some reason you do need that, local hardware access kind of that a generic distro would provide to you, I think you can either just try to make it containerable or containerizable, or just you would have to hold off for a little bit.
Okay, we have 2 more questions.
One comment to a colleague about the Postgres. I think the Flatcar is so minimal that even if you try to run the Postgres on the OS, there might be some missing dependencies on the system. So running as a container is much easier, I guess.
Yeah.
And one question, because maybe I missed that. What's the difference between a Flatcar and a Fedora CoreOS? Because they looked so similar, and I use Fedora CoreOS. Is a Flatcar better?
My personal biased opinion is that yes, it is better. I would say there's 2 main reasons for that. The first one is we simply have more users, so you have a bigger, community user space, right? There's just, more people have dabbled with it, more problems have been kind of raised and fixed. But also we are based on CoreOS, so we kind of do share everything that is great about them and, just add more. The second one is technical. There are certain things kind of on the low-level side of the operating system. For example, we use the Verity for making sure that it is immutable. They use, I think, like OS3, something like that. It's like imagine a Git repo with like every file on the operating system being there and then the hash for that file in that. It basically gets complicated. So we use different tooling to achieve sometimes same things. Also, our Nebraska server, which is the thing that updates you automatically, which, by the way, you can just host yourself and like have control over your entire fleet, right? I would say it's much more robust and kind of developed.
Okay, one more question.
Hey, just a short question. Do you support Sesja Linux?
We are working on it. There is a guy called Krzysimir. You can join Discord and just keep asking him about it if you're bored and you want to be. Yeah, I shouldn't. I'm sorry, Krzysimir. Yeah.
Okay, we have another question from the stream. Why use grub instead systemd boot when systemd is widely used?
We use both. So you can choose. I think in this case, you just use grub on the example, but you can use both, essentially.
Okay, great. Do you have any questions? Okay, one more.
Yeah, so since this is a project that was stewarded by Microsoft and you also said that you work with Azure, why isn't this like the default OS for AKS instead of this, Azure Linux, which is...
This is a very good question. I would say it's an ongoing development. Okay. Yeah, so we were actually in preview on AKS for a little bit. Right now, there's going to be something new that has also something to do with a Flatcar. I'm just saying that because I'm not exactly sure how much of that is public, so I don't want to say anything. But it's a valid question, and yes.
Okay, thank you again, Jan, for presentation.
Thank you, everyone.